Okay, now we are live. We are in live, I think. Let's just wait a minute. Let's just see we are live in Twitch as well. Am I? Not yet. But yeah. Yeah, now we are live and okay. Yeah, we are live in both platforms. And I just want to share this. Come on, guys. Let's master. Let's just master Rust. Okay. Oh, it's playing. I don't like it. Ooh. Yeah, now I think we are good to go. Yeah. Okay. Maybe, but okay. So where we are now, and so if you are new to the live stream, we are just covering this. We are just trying to master Rust. To be honest, that's what we are doing. And we are going to use this book called Rust Programming. I mean, it's I don't know what is the name of the book, but it's I think it's called Rust book, and it's a very good book, and it's have a lot of information. I don't know whether it's cover entire features of Rust. I mean, you know, pretty advanced or something like that. But I think it's covered a lot of things in Rust. It's a pretty good starting point if you are learning Rust. So we are going to I think previous live we are covered these chapters, first chapter, second chapter, and we are covered up to functions, I think. Unfortunately, I have some trouble with my power connections last time, so I couldn't properly streaming because sometimes sometimes the power goes off. It's kind of very annoying. Okay, but I hope today we are going to cover a lot of things. So, but it's a pretty good book, and so we are not but we are not going to like go through this chapter line by line because that takes so much time, and I don't think it's worth it. But what we can do is just go through the concepts, work with build some tiny projects with it, and move on. So that's what are the things we have to do now. So last time we are creating this guessing game, and just a very simple, very simple thing you can build with Rust. Not only Rust, you can build with any programming, but very simple thing. So okay, just wait a minute. And so set. So another thing, okay. So I think we just covered data types, and yeah, I think we did cover data types. Okay, let's jump into the function chapter. Functions. Okay, in Rust, it's simple, very simple. Functions are kind of functions are used to kind of like whenever you want to do something, and you know that it's going to be we are going to be use this very often, and this block of code going to be uh, repeated multiple times in our actual in our main implementation. So if you know something like that, when you're coding in any language, you can use this function feature called function. It's simply a block of code. When you call it, it's when you call it, it's going to be executed. Think fancy, it's just a block of code. And this way you can this is the way actually you can declare function and Rust. You need to use F1 keyword in front of it, and this is the name of a function. This parenthesis just this two brackets just basically indicates that whatever, if you need any data, anything from the user, you can declare here. And if user pass something, then that's going to be saved in this. Okay, it's a variable. Okay, you can declare variable inside of it, something like this. X is a variable and it's I32 type. Okay, and so this is now we are declaring two parameters for this function. It's going to be get two argument. So we will call this as an argument, and we will call this as a parameter. Okay, and this thing so the thing about Rust is that everything in Rust is an expression. What I mean by that is expression is simply evaluable to resultant value. Something like you can think of it something like 2 into 2. It's a 4, right? It's that expression is evaluated to some value, right? 4. So that is what it's evaluates to resultant value. So that is what expression. In Rust, everything is an expression, which is basically meaning that everything you're writing in Rust kind of expression. You can let's give you an example. Let's just wait a minute. Maybe we can create create new example. So if you see into this, oh, I just misspelled that. Sorry. I'm typing very slowly. Okay, let's just increase the speed a bit. So nvm main dot, sorry for that, this is not the file I want to open. And yeah, so we have here we have something like here we have my main function. And okay, we are going to delete this line and say we are declaring some block. It's a block. And um let's say I let's say I just typed 5. Okay, and so maybe we can do something. Just wait a minute. Let's just create a let keyword called x, and you are going to do you can do something like this, something like 5. Okay, so now what you need to understand is that this variable going to be take a value of 5. Okay, so this thing, okay, this block which is I declared is a expression, which is basically meaning that it simply evaluates to some value. Okay, in this case it evaluates to 5. Let's just run this. Print ln. Okay, this is the value of x. Okay, this is the value of x, and we are going to declare x like this. And right, let's just set it to example and cargo.run. Okay, what is the problem? Okay, add here. So this is one of the thing we need to understand, which is that here we just forgot to add a semicolon. To be honest, I'm not really good at Rust though. The value is 5. So now you can clearly see that I just this bit, and yeah, here you can clearly see that this is the value of x, which is, you know, now you can uh, this thing is basically evaluates to some value. So I'm not here, I'm not return something or used any, I didn't use any return statements or anything like that. I just create a block and put something, some number inside of it. Okay, then I just evaluate to that value. So that's why they call this as a expression. Okay, this body is a expression which is basically evaluated to some value. So that is what they are trying to tell us, is that because in Rust is an expression based language. Okay, so this is one of the thing, and he actually used the statement and expression creating a variable assigning to the let keyword, and okay, understandable. Function declare definition are also statements. Function definitions are also statements. The entire preceding example is a statement in itself. Understandable. As we see below, calling a function is not a statement because it's going to be return something. Okay. Statements do not return value. Therefore, you cannot assign a let statement to another value. As the following code tries to do, you get an error. So what they are trying to say, okay, the statement do not return a value. Okay, therefore you cannot assign a let statement to another value. As the following code tries to do, you will get an error. You cannot assign a let statement to another variable. What they are trying to say here? Function definition also, or also statements. The entire preceding example is a statement itself. Okay, as we will see below, calling a function is not a statement. Okay, that's understandable. And statements do not return values. Statement do not return values. Okay, that is what statement means really. Makes sense. Therefore, you cannot assign a let statement. So let statement is let is a statement. Therefore, you cannot assign a let statement to another variable. As the following codes try to, you will get an error. This is a bit of confusing, but To be honest, I feel like a stupid. Let's just ask the GPT. Hey, you can you just wait a minute? Why am I? Hey, can you explain me this? Hey, okay, Rust statement is a expression. Okay, understand. Evaluative value can be used in a variable assignment. Okay, perform an perform an action. Do not return a value. Okay, and what's happening here? It's a statement. Okay, it's a statement. You are trying to assign. You are trying to assign a statement to a variable x. We are trying to assign a variable to x. Of course, we are trying to do that. This is invalid because statement do not return a value in Rust. So you cannot embed a let statement inside another assignment. Interesting. This is like to trying. This is like trying to do this plain English. Let x be equal to declare y as 6. That doesn't make sense because declare as a y is an action, not a val. So yeah, that makes sense, but what is the thing I don't understand is that these things, what they mean. They mean, is it expression like this and Rust? Maybe I'm right. That's a great question. Okay. And yes, there is a difference between this and Rust, even though example is representing a value, represents a value of a unit type. It is a valid expression. Okay, it is a represent a value of unit type. Interest represents okay in a unit type. Sorry, I'm not paying attention here. Concentrate. The unit type like void in other language. Okay, represents a value of unit type. Valid expression, the default return value of a function that returns nothing. Kind of a placeholder that means no value or just did something. Still I don't understand clearly, but result is bn type. It is still a value, just an empty one. So what they are saying is that this is a value type. Okay, unit type represents a value of unit type. So there is a lot of types, right? Integer, struct. So unit type is one of them, I think. So valid expression, default return value of the function that returns nothing. The kind of placeholder that means no value or just did something. Okay. Is anybody in our live? Yeah, block of expression is a block. It can be contained. It's still a value, just an empty one. Understand? So block it's contain multiple statements end with the expression. It's become the value of the whole block. If it ends with a semicolon, it returns something. No semicolon, this serves the return value of the block. Now back to your code. Using to group statement, it's a statement, not an expression. Okay, let y is equal to 6 is a statement, not expression. So let x equal to brackets expects an expression inside a expects on, but it's got statement. I feel like a so stupid because I couldn't understand the simple thing like this. But this is what I just understand is that this thing, these brackets, or kind of you can say this will return something. By default it will not return something. It's a unit type, which is a type value, and it is a value without any value. It's kind of a empty value. Okay, whenever we put this, it's going to be written empty value. Okay, but it will return something. Okay, so that means it's not a statement, it's an expression. So if you are putting this, if you are putting something inside of this, which is a statement, so your statement is basically not returnable, right? You cannot assign a statement to something. So they are basically saying that if you put expression instead of these blocks, it's going to be returned that. If you put a statement of this in the statement of these blocks, okay, it's going to be returned that. But you are assigning a variable. You are assigning you are declaring a variable and assigning assigning that statement to the variable. So this is basically not working because statement do not return values, right? Expression only value two values. So that basically meaning that we will not assign those. Let y equal to x. So that this will not basically work. It will and yeah, I hate to see my typing speed. It's very slow. I don't know why. It's because I'm nervous. No, I'm not nervous. Mm-hmm. Statement does not return a value, and that is in any for anything x to bind to. So this is okay. We understand this thing. Thing. Statement does not return a value, so there is in anything to bind to. This is a different value. What will harm this? See in Ruby, where assignments return a value of assignment. In this language, you can write this and have both. So here, this thing is a statement, and it will also return a value. So that's why we are, and that's why in those language C and Ruby, where we can assign those both and y as a x and y, both x and y to 6. But that is not the case in Rust. To value except most of the rest of the code that you will write in Rust, consider the math operation also 11 and be apart. Sometimes expression can be part of a statement. Of course it is, as long as they are not returning any value. Therefore 6 is an therefore 6 in the statement. Value calling a function is an expression, calling a macro is an expression. Okay, calling a function is an expression, calling a macro is an expression. And new scope block created with curly brackets is an expression, which is we just did before. This is that thing is an expression. Okay, F1 main. So it's just an expression, so it's evaluated to some value 4. So this thing is basically saying that hey, I have a function called phi, and it's a return type. You are mentioning the return type. Basically, this is the type it's going to be returned. Simple, right? Makes sense. Functions can return value to code that calls them. We don't name return values, but declare their type after an error. Sorry, error. And Rust, the return value of the function is synonymous with the value of the expression. Okay. So all you need to know is you can define something like this. One of the thing about learning programming is that it's really one of the very important thing we can miss easily, which is that if you learn something, if you are already familiar with some other programming, whether Python or Java or JavaScript or whatever, now you are learning new language, so it's really easy to skip these minor details, right? these expression, statement, these kind of things, it's really easy to skip, because once you learn something, you're you and you are going to learn another thing which is a category of the same within the same category, and your mind is normally looked at as a new thing, is kind of not a different thing, but it gives you a feel of this, like even though I'm not know you very well, but I can understand you easily. So it's give you a familiar, very familiar feeling, like, this is something like that and that. So you can easily compare those. It is very easy to make analogies, right? Analogies, you can easily make analogy to other language, right? You can make compare them, and so this feature is kind of like this feature in this feature in Rust is kind of like this feature in Python or something like that. But even though so people want not, I don't know, but that is what I'm thinking, is that whenever we are trying to know learn new language, we will miss a lot of new little details, very little details, which is going to be really important if you want to really master something. So it's really important for master something, other than what I'm saying is, now what we are doing as simply what I'm doing is right now is that simply reading the text and explaining to you, and code a bit, right? So but still I'm not a master in Rust. I'm not expert in I'm not, my expertise is not in Rust. Okay, so that just basically meaning that even though I can code in Rust. Okay, I can understand Rust code, really. Okay, so if I look at some code in Rust, I can understand them. Okay, this is that, this is doing this is returning this is calling this, and blah blah blah. You can do that, but still I'm not master. So even though I can understand the Rust code, by still I didn't know about this difference, this thing, still I couldn't explain this thing right away, right? So I just need to pass. So this mind I just need to pass. I should how I put this, I don't have any other choice to other than a pass and think about what it is, why it's, and ask and understand. Oh, this is what it is. Okay. Even though I can understand, even though I can write, even though I can read the Rust code, I couldn't give the solution to right away. Okay. So this is how you feel like this is the difference between mastery and familiarity. Okay, mastery is totally different thing compared to familiarity. So in programming, I would say in programming, most of the people's, I seen a lot of people's. Okay, so a lot of them are familiar with programming, not mastery with programming, because they would say how many language you know, right? So if you ask somebody, I mean, I'm not saying all of them. There is lot of mastery peoples in lot of languages, but it's so easy to get familiar. But now it's very rarely, really hard to get mastery. So if you ask somebody how many language you know, they would say, I know two language, I know three, I know five, maybe six, seven. But they're really hiding this fact of, if they they at least have to have some years of experience to learn that much of language very well. What I mean by that is mastery, right? You cannot master something without yeah time. There is yeah, people are obviously there is a lot of smart people. Somebody is learning is slow, somebody is learn it's very quick. So there is a lot of them. There is a difference. Yeah, of course, I'm saying is what I'm saying is, of course, there is a difference between the people's learning and how much time it takes to learn something. That's not going to be same for all of them, all of us. So it's going to be differ for me, you, everybody, right? But the thing it's going to be take to master is it's going to be it's going to be a while. Okay, you cannot master a thing right away, right? But you can get familiar with the thing right away in programming. So that's what I'm saying. You can even though if you are master like code in C or Rust for 2 years or 3 years, you might think that I'm a master now. I'm a master in Rust now. Yeah, of course, maybe that's true. Of course, yeah, what you learn, or if you're learned and work truly hard, you're going to be master at Rust. But at the same time you can have this chance of working 3 years in a particular language, even though you didn't master them, but you think you did. So that thing is really one of the thing in programming. I don't know about other fields, maybe other fields also have these kind of things as well, but basically what I'm saying is it's really very easy to get familiar with something. Get familiar with something is really very easy, and in programming it's really easy. You can get familiar. Okay, this is if, this is why, this is for loop, this is a statement, this is an expression. You can get really familiar with something. But the true mastery and the true understanding of the language is totally different from the familiarity. So this way of saying that it's kind of like so you need so this is one of the thing faced a lot of the times is that I just read some language and understand it, okay, then I realize that I'm good at it. That's not true. That is not true. It takes some time to understand. It takes some time for me to understand that familiarity is different than the mastery, or truly understand. Okay, if you get familiar with this language, you are not truly understand them. You just, okay, you just kind of like memorize this. Okay, this is this, this is this, but why this is a whole different thing, and you don't know nothing about it. So that thing is only came from, in my knowledge, that thing only mostly came from by doing something, not by reading something. So let's say we are now I'm writing and explaining what all of the things are, and but this thing won't work for if you want to truly understand any kind of language, anything. If you want to learn something truly, you need to do something about it. You need to create something with it. Okay, then you can learn something. Okay, even you did, you cannot say, okay, I know everything about this. No, you cannot do that. But you can say something like, okay, I'm pretty much, I know something about this. Yeah, mm, well, the reason this thing is the reason why I'm telling is that this thing is very easy in programming, and That is what it is. And I faced this when I really learn programming. When I faced this challenge many times, I still it takes me some time to understand. Really, not some time means something like more than a year to understand. Okay, it's no, I'm just familiar with it, not truly understanding this thing. So most of the times I made a mistake. Most of the times I just did this mistake called leave the small things. Just leave the small things, take care of the big things. That thing is really I don't know this is a good approach for learning or not, but that thing is directly jump to something like intermediate level. Don't learn basic stuff. Just okay, those other things are don't we don't have to worry about something like that. I always did something like that. I always don't worry about basic stuffs. I always focused on advanced and intermediate stuffs. But I get to the point where I really very terrible at basic stuff. It's really hard for me to break this brand. How I can put, I don't know how I can put this. I'm good at advanced stuff. Oh, I know this thing is working, this is the working this thing. But without the basic stuffs you don't know, you can explain why if something if you face any challenge in the without the solid understanding of the basic stuffs, you will not say, you will not you cannot say you cannot give a solution to that problem. So that this is the main point is this is this mental imaginary thing where basic stuffs are very easy, so you can for me at least what I'm saying is not everybody be facing this. At least for me, I'm faced with this issue. So it's basically the imagination, some kind of imagination, something like this thought something like you don't have to worry about basic stuff. Just focus on advanced and intermediate stuff. More than intermediate stuff, focus on advanced because they are the hardest thing. If you get familiar with it, if you understand truly, you can understand the basic steps very easily. And even you don't how I put this, even you don't without get turns without get your I don't know how the I don't know the right word for it. So that's one of the mistake I did. It's really, yeah, it cost me some of the time. Yeah, that is. Let's focus on okay. Okay, it's a return type, nothing fancy. So this is a function 1 plus, and this is a parameter, and this is the type of the parameter, and this is the return type. Nothing fancy, okay. So same thing. Okay. And commands. So commands is basically something like if you want to say something about the code, yeah, let's say if you want to type something in the code interface in the actual file, actual the code file, and you can do this by double slash. If you did that, machine know that this is for user information. We don't have to touch this, so we should not touch this. Not. My English is terrible. I can see that clearly. I'm mixing all of those things. Lot of words. But there is no other way. The only way to learn something by doing something. Okay. So fn main. So this is a main function. I'm feeling lucky today. So this is for command, and this is also a command. Okay, control flow, and this is a control flow is a, if you are familiar with the if else statement, I don't know. Simply, if you have a condition, okay, you have a condition. If the condition is satisfied, execute this block of code. If the condition is not satisfied, execute this block of code. That's it. We are assigning 3 to a variable number, it's a variable named number, and if it is less than 5, this block of code will execute. If else, if not, this block of code will execute. Okay, and just basic stuffs. And here we are checking a true or false. Basically, if it is have some number, okay. If it is don't, it's going to be not executed. Basically 0 or 1. If it is a 0, it's not going to be executed. If it is a 1, it's going to be more than 1, it's going to be executed. Same thing for this. We are checking if number is not equal to 0, execute this. Same there here as well. So here we have a multiple expressions, something like this is one condition and another condition and another condition. If none of this if none of this is executed, just execute this. Nothing fancy. And this is basically kind of what they are calling this. What is the name of this expression? Is right to how are you calling this? Okay, this is just a mini inline if else statement. You can think of it as like that way. Just if condition condition is a variable, and if it is a true, return 5. So this is an expression. Okay, so it evolves to some value that is 5. If else, it is 6. Even if it is true, this will be executed. If it is false, it's going to be. And here so same thing for here as well. I think if it is this, execute this. If it is not, it will not. But there is okay. Let's just read this here and let number equal to if condition is if condition is true, this 5 will be returned. Else 6, it's a string. Expected integer found. Expect because of this. For more information, okay. So let's just when you are trying to compile this code, we get an error if else non type compatible. Okay, so this is one of the thing we need to understand. I think that the both of them, this thing and this thing, should be a same type. So just return this. Do something like this. Why am I typing so bad? It's really Didn't they both of them are oh my god, this is also different in Rust. Why it's not? So this thing is a string literal, but this thing is a number type. So both of them need to be both of them need to be same type. Version the if a block execute the integer and the execute the string, this won't work because variable must to have a single type. Rust need to know at the compile time which types the number variable is. So the compile time, it's need to know, the compiler needs to know the type of the number. So but it cannot evaluate the logic. So that's just basically mean that the number, if it is need to know the number type of the number variable, and then we are using a logic here. So that means based on the condition, it's going to be the value, the type of the variable named number, it's going to be changed. So the compiler won't any choice, okay, won't have any choice to give a error, because if you assign both of the value, if you assign the logic to be give a single data type, like if here like writing a if else condition, right? If it is going to be you can create now basically it's going to be changed, right? It's going to be changed according to the variable condition, right? So even though it's going to be changed, but we are retaining the both we are retaining the value as the same type, right? It's a whether it's a if condition, whether it's a if condition executed, whether it's a else condition executed, both of them going to be written the same type, which is a integer. We just change it to string, right? Both of them have is a string type. So the compiler don't have to worry about that, because even though it's a logic, even though the value can be changed, and but the type is there is the both of them is going to be a same type. So that's just basically meaning that we don't need to worry about. So that's why the compiler force us to do this. If it is like this, the compiler will have you know couldn't guess which type the number's going to be, number variable going to be. That's it, what it is. Let's just see. uh, just wait a minute, I will be back in a minute. I will be back in a minute. Just wait. I'll be back. Okay, I'm back. We are back. It's really hard. Just let's just wait a minute. Yeah, now we are back. Okay, so 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 this is why compiler forces us to just hey return make the type consistent, which is basically mean you can write logic, but you cannot write logic for different data types. There is a loop, while loop, with just a loop keyword, and while and for. So this is basically saying that you know this thing and the loop keyword, this loop keyword is kind of new. I never seen any other thing, seen something like in Python or in C. In C we have a for loop, while loop, do loop, do while, three types of loop. And this loop is bit of a different, which is basically mine. If you declare this this if you declare this loop, and it's going to be executed for forever. It's not going to be stopped, right? So it's kind of like a loop. It's going to be run forever, and you can break this loop only with the break statement, something like that. If you use this, you need to mention some logic and break it, otherwise it's going to be run forever. And while loop is kind of the same thing, you know. If the condition is okay, it's going to be run. If it is false, it's going to be break. For loop, it's you know, just a for loop is for just do this. If you know how many times the loop going to be run, hey, I want to run this loop for 10 times, you can use for loop. That's it. So for loop is the another thing. For loop is here is used for retrieving elements from the array or vector or tuple or whatever. Just basically mean that this is an array, and it's going to be take every single element of that. This is simply you can think of it as a, it's going to be give you number from 1 to 4. That's it. I don't know what this dot reverb method do, but let's just check this. 3, 2, 1, which is basically the, maybe it's I think it's basically do changing the order, reverse the order, right? Normally it would give 1, 2, 3, 4 without 4, and now it's going to be 3, 2, 1. Summary. Okay, understanding ownership. This is now we are getting to Rust, actual Rust. So this ownership feature is kind of one of the unique feature in Rust, which is not present in C. That's why this is one of the feature makes Rust so safe when it comes to memory management or something like that. Is because so Rust is let's just read this. Let me just read this for you. Ownership is Rust's most unique feature and has deep implication for the rest of the language. Okay, it enables Rust to make memory safety guarantee without needing a garbage collector. So the Rust basically doesn't have a garbage collector. Okay, so it's kind of a okay, we will come to that later. And so every other C have a garbage collector, JavaScript have it. There is a lot of other language have a garbage collector, which is basically removing the unused values. So we will come to this again. Because once you know these garbage collectors and this ownership and borrowing these kind of things very deeply, I would say you understand one of the most important feature in Rust. So it's important to understand how ownership works, and in this chapter we will talk about other talk about ownership as well as several related features, borrowing, slice, and how Rust lays data out in memory. Okay, that's another. Okay, that's sounds good. And ownership is basically simply how I put this. So whenever you create a variable, it's going to be created in a memory, right? There is going to be address for that memory, and the length size of the memory, and the variable going to be pointing to that memory. You can think of it as like, so this ownership thing is basically meaning that, hey, I have this um I have this address and I'm the owner of it. Okay, so I'm the owner of it. Just basically mean if I create a variable called x, then I assign a value to something like a 6. So it's going to be it's going to be stored in stack memory with the address, right? So the x variable is the owner, basically saying that, hey, I'm the owner of this address. I can change, I can read the address, I can change the address. So that's so this ownership thing, when you assign a value to when you assign that x to another value, that is going to be a two thing. Okay, one of the two things should be happen, because other than you cannot do anything. If you assign let's say x have a value of 6 and you assign it to a y, whether it's going to be either it's going to be create a new memory and store as x store as 6 at that memory for y, or it's going to be transfer ownership. So this copy thing supported in many data types, which is basically some of the data types should not create a new some of the data types will not create a new address and put those value, copy those values. So some of the data types won't do, some of the data types will do. And so the ownership thing is basically you can transfer one of this. That's the thing, that's the one of the very important thing, which is basically meaning that I have I have a value 6 and I am the owner of this address. Whatever it's going to be in that address, I'm the only person can rewrite that. Okay, and you can rewrite it, which is, this is one of the careful thing, this is one of the important thing in Rust, which is sometime you can borrow, or you can borrow memory, borrow the address and see what inside of it, but you cannot change the value. So that's the borrowing topic. So the ownership topic is simply, I'm the owner of this place, so I'm the only person going to change whatever in it. I'm the only person going simply I'm the only person can change whatever in it. No other person can change. So another thing is, no other person cannot reference this, which is basically meaning that mutable reference. So mutable reference means basically simply meaning that, hey, I have this address. Okay, so mutable reference means I have this address, I can read it, I can write it. So mutable address means not allowed, which is basically mean two variable cannot to point to the single address with the both of them have this access to write what's inside of it. You cannot do that in Rust. So that's why it's encourage safety. So that is simply ownership. So you can transfer ownership, which is basically okay, now you can take the okay, let's say x is a owner of 6. Okay, now you can make a y also, a y as an owner of 6 instead of x. Once y become the owner of 6, x cannot be changed, the 6th value, the value of 6. Okay, he no longer a owner. Okay, that's the only owner, but you cannot create a multiple inspect one. What I mean by that is, you can borrow the memory. You can borrow. Borrowing means basically you can inspect what's inside of it. You can inspect it. Can inspect just what's in the, not only one variable, multiple variables can inspect what's the value of this mattress. Let's say y is the owner. We have Z, A, B. Both of them have borrowed memory, which is basically it can see what is the value in the address, which is y have. Okay, which is y won't. That's that's the pretty much everything in sir. That's the pretty much everything in uh, ownership and borrowing. As long as you create a new owner, the old owner will be vanished. Basically, the three things: ownership, borrow, and new copied memory, new memory. So each value in Rust has an owner, and there can only be a one owner at a time. That's what I'm saying. When an owner goes out of scope, the value will be dropped. So another thing is, whenever, so maybe you can just, we can show an example. Just wait a minute. Okay, we have a let x equal to 6, right? And we are creating another variable called x. So basically saying that, let's just create again x, and it's going to be 6. Println, this is, why am I typing so badly? This is x inside of the block. Okay, and you just need to that's it, right? So we don't need this line, do we? Why am I removing unwanted, unused thing? Is that Rust compiler will tell you that, hey, this variable is declared but never unused in the code. It will do that. And when you run the code. Yeah. Sorry for that. Here I'm also declaring this as a, maybe we can declare this as a 3. Now let's look at this. Here you can see that this inside of this block, x is changed to 3, right? Then its x is changed to 6, basically meaning that once this block is executed, this x variable, it's not this x variable. Okay, this x variable created a new memory and allocated a new space and have a value of 3. So once this x is out of scope, 3 will be deleted. Just the bar, just the we don't need the x anymore. So yes, x let x is hello. We are creating this, and yes is not a validity here. It's not yet declared. It's valid from this point forward. Okay. So and another thing is we have already seen a string literals. You can create a string from literals using a function. Okay, let's just ask ChatGPT because it's going to be give. What is this from function? Data. What it does? Take the string. Take the string slice, which is okay. Create new heap allocated. So this is a heap allocated memory. See what you. So another thing, it's one of the important thing. What do you mean by slice here? Slice is a view into a sequence of elements. It does not own the data. It's just borrowed the part of something else. Oh, now I can understand this. Like a string or slice is a borrowed, not owned. Just a it's just a borrowing an address and what is a slice in Rust? Rust is a view into sequence of element, does not own the data, it just borrow the part of something else. Okay. The point of this part string slice, a borrowed view of string. Yeah, basically borrowing. I just explained what is borrowing. That is what's also slice does, but string slice is borrowing a string element. And as far as I know, it's going to be have a length of that array, if it is a slice of an array, it's going to be have a length of that array and the address of that array. It is efficient and safe. Yeah, yeah, pointer to start of the element and length. How many elements to read? So that is how it is. Slice does not own data, but it can visit or it can see what's inside of a memory, something like that. So string, own data, mutable, type string. So this is a pointer, no own data, no mutable, it's a borrowed plus no mutable. Type slice, okay, understandable, and hello, and this thing, which is going to be give the address of whatever you put inside here. And another thing, here we have a t, no, no, which is the same thing. So the here we treat t as anytime. So this is going to be a common, we can call it as a generics. So you can call this as a generics, which is basically mean t is basically referring to any time. It's going to be, it can be any time. Okay, let's just go through this. Actually, we just forgot why we just asked this question in the first place. We want to understand this from. So what does this from method do? From function or whatever. Type string allocated heap memory. So the thing is, it's allocate heap memory instead of stack. Whenever you create a variable, it's going to be allocated in a stack. So you don't need to care about this deallocation. So, but in a heap memory, you need to care about this. global mutable string. It owns its content. Can modify, append, or free whenever it's out of scope. So you need to do that. Static memory. Heap allocated. Simple read-only string returns. You need to build and modify and own the string. So this thing going to be live in a stack, and this thing going to be live in a heap. Understand what I'm saying? Makes sense, right? It is a pointer and it is a string type. Okay, what do you have? Creator and okay. So this trade is not in not in this type. So the trade thing is also one of the important thing of trust. Very important thing. And trust we will see in a bit. Pointer to this address. This first index, length 5, capacity. Yeah, it's going to be 5. For this thing. Pointer to both of them are pointed to this address. This is you can think of it as a memory, and this is a variable, and it have a pointer reference to this address. This also pointer reference to this address, but both of them are borrowing, not a owner of this. So there is someone should be, I think S1 is the owner of this and S2 is borrowing this. So this is how copying works. Instead of this is both referencing to the single block of memory, allocated memory in a memory. So this is S1 and S2 have a both distinct value with this distinct memory with the same value. And hope this all makes sense. That's it. This is pretty much about how memory works in Rust. There is a lot of things. still we need to take care if Rust copy the keep. Okay, another possibility for the world might do if Rust copy the heap data as well. Okay, but this thing is not you cannot do this thing for all data types because some of the data types do not allow you to copy those memory and put it in a new memory. You cannot do that. Copy the memory, you cannot do that. So this thing is basically he is what is this? Why it's in a different color if you heard the term. So shallow copy, deep copy, which is these are the this is one of the very important thing in Rust. Not only Rust, this thing is also in Python, which is basically mean the shallow copy is basically you're not actually copying them. You are just basically you are just have the reference of them. Let's say I have a x and I have a y. I'm saying x is copied to y, which is basically meaning that x is not copied to y. It just if it is shallow copy, which is basically meaning x, y have the address of x. Okay, so you can it can read. Okay, that's what is this shallow copy. Deep copy means the exact value is going to be copied to the new memory. That is what deep copy. The another thing, I don't know how it's how Rust behaves, but this is how it is. What about this? When you create this, it's going to be mutable variable, then you reassign to this. So the hello thing, it's going to be in a memory, but it yeah, that's yeah, here you can see that the heap thing is pretty tricky here. You can clearly see that this thing is going to be I'm not sure whether this exact thing will happen in stack memory, but what they are saying is that we are initially declared a variable yes. First they declared some variable yes, then bind some string value to it hello, then immediately create a new string value a boy hi, how can I pronounce this? HOY, whatever it is. And then assign it to the this. At this point, nothing is referencing to the original value on the heap at all. Basically, meaning that even though we are first referencing this, then we are changed to referencing this. But this thing is going to be live in a memory. So the original string thus immediately goes out of scope. Rust will run the drop function on it, and it memory will be freed right away. So this is the thing Rust really does well. So here you can see the original string thus immediately goes out of scope, and Rust will run the drop function on it and memory away. But if you are using a pointer here, something like in a C, it won't happen. It will not happen. I'm not sure it will happen or not. We change a value to no. For changing value, it will happen. But for clearing value, you need to explicitly do that. but there are some of the tools for it, but still this is the idea. So but if you don't this drop function is basically doing that work for you. Basically it's not a computer itself doing something like that, but this drop function and this and the drop function is basically, oh okay, this address is no longer referenced by any of the variables, so we can do this, we can delete this address. Without this function, no. So I think the clone thing is basically a copy, deep copy, deep copy the heap data of a string, not just the stock data. You can use common methods. But because methods are common, okay. Stock only data. There's another I think we haven't talked about yet. Code is so this is basically what here what you how can I put this? So basically what's going on here is that this X is decopied to Y. So both of them, Y is not referencing X. It just created copy of X. Even though we don't have to call clone, it's because not all the things in Rust, not all the thing in Rust will not do this defaultly. This works for integers, but for string it will not. You need to call some method. So you need to define some trade on that method. Even though but the thing you can do with the Rust is that you can define a custom data type or custom data type on and define a trade for it, subcopy, or you can define a copy trade for the inbuilt data type as well, so that you can just copy them without calling any explicit functions. So we will see that in a future. So another thing is that stack memories are very fast compared to heap. Whenever I create a variable in stack, there is a lot of I think a lot of the things. There is many things you don't need to worry about. So this is what I just mentioned. They can, they have copy trade implementation for I32 to I32, but for I32 to string, we don't have that yet. That's one of the reason trade is very important. Trades are very important in Rust, but you can define on your own. The mechanism functions are similar to those when assigning a value to the variable. Passing a variable to a function will move or copy, just an assignment does. So whenever we send some data to a function, either it's going to be copied or moved. And what I mean by that mode means, mode is basically transfer the ownership, and copied means basically copied, and that's it. So X comment is scope. Here you can clearly see that yes, this is in scope, and we have some function. So X value move into that function. So this X no longer owner of this hello address. So the new one will be something. New one will be something here. This variable is going to be a owner of this. Okay, so the executions jump to here, and he is going to be owner of this hello, and he is come into the scope, and we printed. Then this variable just out of scope, and here out of scope drop is cancelled. The backing and the memory is fried. So does this mean yes, do no longer have the value of hello? Let's just here we just make this as a mutable variable instead of um, so before that, just make this as a mutable variable, And here, just oh my god. Gentlemen, what what will have to yes. Okay. Let's just say so we don't need this now. Whole lot of error. So remove mute. Okay. So that just basically mean we only can read the heap memory, not changing the. We cannot change the. But I think let's just do not do mute this. Okay. Still a lot of error. So this is basically like saying that it does not have a copy, but we moved here. Why we need copy trade here? Moved into the function. Value borrowed here after move. Yeah, once it's once this function is executed, this string, this addresses will be deleted. Basically, this is out of scope. So the no longer this going to be no longer this is going to be a owner of this address. That is what it's actually mentioning here. See, you can see that by this Rust compiler is very friendly. You can read a lot of you can learn a lot of things from it. Mm, okay, return value and the scope. So this get ownership function going to be return something this. So whenever you call this ownership is mm, just basically transferred to s1. Then this is creating a new variable, and now now s2 is sent to this take ownership this, and that thing is written going to be written this, and this thing is basically moved to s3. So here you can see that the way of like moving and copying, the difference between them, it's a pretty handy thing, and it's one of the important feature in Rust. Not only Rust, every programming language have this feature. Every programming language, um, this is a feature of every programming language: copy and move and copy. Yeah, the move thing is not in all language, but the copy thing is in pretty every language, but referencing is in all language. Not all language. In C you can do that, but yeah, no, it isn't. It is the core of all language, but some of the language you can do that explicitly. Some of them you can't. So the drop thing is whenever will call whenever the variable out of scope. The value will be cleaned by the drop unless the ownership of the data is moved. The drop won't be called, but if not, the drop will be called. While this works, taking ownership and returning ownership will with every function is a bit tedious. What if we want to let a function use a value but not take ownership? It's quite annoying that anything we pass is also need to be passed back if you want to use it again. And this is one of the important things. And in addition to a data, so you need to make sure if you want to use that ownership again, you need to make sure you need to make sure you are returning them, or if you don't, you can create a copy of it. So that's going to be copy a argument and use it that, but that will not change anything to this. But if you created a variable and send a copy and modified something and return something, and you need to make sure this thing is moved to that thing. That's all. It pretty much yeah, moving part. Okay, the moving part is how Rust works. So even though the parameter is copied, then after the computation, you are going to move the parameter, right? If you move that, you can create a copy or move. If you move that, you need to assign it to the old variable. But if you want to assign it to the old variable, you need to set it as a mutable variable. Okay. So if you set it as a mutable variable, it's going to be change the value in the address. So you cannot do that without declaring a variable as a immutable. So while works taking ownership and returning is kind of a tedious. Okay. It's quite annoying. In addition, you need data, but you can do that. You can do that with the copy traits. You can define a lot of traits. That is a bit advanced, but we will cover that in the future. By boarding of the function that we will might want to result as well. Okay, so this is creating string data type, and another thing is it's kind of destructuring it. So So this is calling this function. It's going to be data type, and this is going to be the returns some. This is a unit type something, and it's going to be length, and s is what it is, and this is moved. This is go here and move to s2, and the length. That's it. So, but to make a lot. How I pronounce this? Ceremony. And lot of the work for a concept that should be common and loosely for luckily for us, Rust has a feature for giving a value without transferring ownership called reference. Okay, that thing we will okay, I think that's it for today, and I think we will cover that in the future. And if you like our live stream, please comment, like, subscribe. uh, if you find it useful, you can share it with your friends, and that's it. Yeah.